Take a deep breath. Let your shoulders drop. Tonight, we're going somewhere peaceful, somewhere infinite and gentle. We're drifting into the cosmos, into the soft glow of starlight, where time moves differently and everything feels vast, yet somehow comforting. This isn't about memorizing facts or studying hard science. This is simply about letting your mind wander through the night sky, feeling small in the best possible way, and discovering why stars might be the universe's most soothing presence. So settle in, get comfortable, and let's float together through the quiet universe. The stars you see tonight have been on an impossibly long journey just to reach your eyes. Right now, as you breathe in and breathe out, photons of light that began their voyage decades, centuries, sometimes thousands of years ago are finally arriving at this exact moment. That twinkle you notice in the corner of your vision, it started its trip before your grandparents were born, traveling through the cold vacuum of space at 186,000 miles per second, never stopping, never slowing, just moving forward through absolute darkness until it found you here, tonight, looking up. Think about that for a moment. The light touching your eyes right now is ancient. When that photon left its star, the world was completely different. Civilizations rose and fell. Forests grew and disappeared. Rivers changed their courses. And through all of that change, this single particle of light just kept moving, carrying with it the story of a star that might not even exist anymore. Some of the stars we see tonight have already died, their fusion cores exhausted, their light extinguished. But we don't know it yet. We won't know for centuries, maybe millennia. Their final light is still traveling toward us, a cosmic letter that hasn't been delivered. Our own sun is a star, of course. Sometimes we forget this simple fact because we see it every day, because it feels close and familiar, because it doesn't twinkle like those distant points in the night sky. But that warm light on your face each morning, that's starlight too. Our sun is a perfectly ordinary, medium-sized star, one of hundreds of billions in our galaxy alone. It's been burning for about 4.5 billion years, fusing hydrogen into helium at its core, releasing energy that takes tens of thousands of years just to travel from the center of the sun to its surface, and then 8 minutes and 20 seconds to reach Earth. Every atom of warmth you've ever felt from sunshine began deep in the sun's core, where temperatures reach 27 million degrees Fahrenheit. At those impossible temperatures, hydrogen atoms slam into each other with such force that they fuse together, creating helium and releasing tremendous energy in the process. This energy, pure radiation, begins bouncing around inside the sun, absorbed and re-emitted by atoms over and over again, taking a random walk through the solar interior that might last 10,000 years, maybe 170,000 years, before it finally reaches the surface and streams out into space. Some of it travels across the void to warm your skin, to help plants grow, to light up the sky. But our sun, comfortable and familiar as it is dwarfed by some of its stellar cousins. There are stars so incomprehensibly large that if you placed them where our sun sits, their outer edges would extend past Mars. These red supergiants, stars like Betelgeuse in the constellation Orion, are swollen and enormous, bloated to sizes we struggle to conceptualize. Betelgeuse has a diameter about 700 times larger than our sun. If you could somehow stand on the surface of Betelgeuse, the sun from your childhood would look like a tiny marble by comparison.
Imagine, just for a moment, a star so large that you could fit more than 1 million Earths inside it. And then imagine a star so large you could fit 1.4 million of those suns inside it. That's the scale we're talking about. VY Canis Majoris, one of the largest known stars, is so vast that if you tried to walk around its equator at a steady pace, never stopping to rest, it would take you about 9,000 years to complete the journey. The human mind wasn't designed to comprehend these scales, and there's something oddly peaceful about that. We can simply let these numbers wash over us, acknowledging that the universe contains wonders far beyond our everyday experience. Stars are born in nebulae, those gorgeous clouds of gas and dust that look like watercolor paintings in deep space photographs. These stellar nurseries, like the famous Orion Nebula or the Pillars of Creation in the Eagle Nebula, are places where gravity slowly, patiently gathers material together. Over hundreds of thousands of years, a clump of gas and dust grows denser and denser, pulling in more matter from its surroundings. As it collapses under its own gravity, the center gets hotter and hotter. Eventually, when the core reaches about 10 million degrees, something magical happens. Nuclear fusion ignites, and a star is born. But this birth isn't sudden or violent like we might imagine. It's slow, gradual, taking place over timescales that make human civilizations look like brief flickers. A star doesn't suddenly switch on. It slowly brightens over millennia, clearing away the surrounding gas and dust with radiation pressure and stellar winds until finally it emerges, a newborn star, beginning a life that might last billions of years. These stellar nurseries are places of extraordinary beauty. If you could somehow visit the Orion Nebula, located about 1,344 light-years from Earth, you'd find yourself surrounded by clouds glowing in shades of red, pink, and blue. Young, hot stars would illuminate the gas around them, making hydrogen glow red and oxygen glow blue-green. New stars would be forming all around you, hidden in dark cocoons of dust. The whole region would be alive with stellar birth, though alive here means processes unfolding over tens of thousands of years, invisible to any single observer's lifetime. The variety of stars in the universe is stunning when you begin to look closely. There are red dwarfs, small and cool, burning their fuel so slowly that they might last trillions of years, far longer than the current age of the universe. There are white dwarfs, the dense remnants of dead stars, packing the mass of the sun into a sphere the size of Earth. There are neutron stars, the collapsed cores of massive stars so dense that a sugar cube-sized chunk of neutron star material would weigh more than all of humanity combined. And there are stars in their prime, like our sun, steadily fusing hydrogen and shining with reliable constancy. Some stars exist in pairs or groups, orbiting each other in cosmic dances that last millions of years. These binary or multiple star systems are actually more common than solitary stars like our sun. Imagine a planet orbiting two stars, experiencing sunrises and sunsets with twin suns, casting double shadows. These systems exist throughout the galaxy, companions bound together by gravity, sometimes so close they exchange material between them, sometimes separated by vast distances, but still gravitationally linked. The colors of stars tell us their temperatures. The hottest stars burn blue-white, their surfaces reaching temperatures of 30,000 degrees Fahrenheit or more. Cooler stars glow orange or red, their surfaces merely 5,000 or 6,000 degrees. Our sun, at about 10,000 degrees on its surface, glows yellow-white, right in the middle of the temperature range. When you look at the night sky carefully, you can actually see these color differences. Betelgeuse appears distinctly reddish. Rigel, also in Orion, shines blue-white. Sirius, the brightest star in our night sky, sparkles with a white brilliance. There are more stars in the universe than grains of sand on all of Earth's beaches. Let that sink in for a moment. Every beach you've ever visited, every coastline, every desert, every sandbox, every grain of sand anywhere on our entire planet, the universe contains more stars than that. Current estimates suggest there are around 200 billion trillion stars in the observable universe. That's 200 000 000 000 000 stars. Each one is a sun, potentially with its own system of planets, its own story of birth and life and eventual death. And we can see only the tiniest fraction of them. On a perfectly dark night, far from city lights, the human eye can see perhaps 5,000 stars. That sounds like a lot until you realize our galaxy alone contains somewhere between 100 and 400 billion stars. We're seeing less than 1/1,000,000th of 1% of just our own galactic neighborhood. The rest remains invisible, too distant, too faint, or obscured by dust and gas between here and there. Stars have life cycles, though they unfold on timescales that make geologic time look brief. A star like our Sun will spend about 10 billion years on what astronomers call the main sequence, the stable period of fusing hydrogen into helium. Our Sun is roughly halfway through this journey, about 4.5 billion years old, with another 5 billion years of steady burning ahead of it. But eventually, though, it will run low on hydrogen fuel in its core. When that happens, the core will contract and heat up, while the outer layers will expand outward. Our Sun will become a red giant, swelling to perhaps 100 times its current size, possibly engulfing the inner planets, including Earth. But this won't happen for an unimaginably long time. 5 billion years is longer than Earth has existed so far. 5 billion years ago, our solar system was just forming from a cloud of gas and dust. In 5 billion years, if there are any humans or descendants of humans still around, they'll have had more time to evolve and change than it took us to evolve from single-celled organisms to who we are now. The Sun's eventual transformation into a red giant is certain, but it's so far in the future that it feels more like a cosmic inevitability than anything to concern ourselves with tonight.
Massive stars, those born with 8 times the Sun's mass or more, live fast and die young. They burn through their hydrogen fuel in just a few million years, a cosmic eye blink compared to the Sun's 10 billion-year lifespan. These stellar giants shine brilliantly during their brief lives, and they end spectacularly, exploding in supernova that briefly outshine entire galaxies. These explosions scatter heavy elements throughout space, seeding future generations of stars and planets with the building blocks of complexity. Everything in your body, heavier than hydrogen and helium, was created in the core of a star or in a supernova explosion. The calcium in your bones, the iron in your blood, the oxygen you breathe, the carbon that forms the basis of all organic molecules, all of it was forged inside stars. You are, quite literally, made of stardust. Those atoms in your body right now once belonged to stars that died before our solar system even formed. They were scattered through space, eventually gathering together in the cloud that would become our Sun and planets, and now they're here, arranged into the pattern that is you, conscious and aware, contemplating the stars that created them. This connection between us and the cosmos is one of the most beautiful insights of modern astronomy. We're not separate from the universe, observing it from outside. We're part of it, made from it, temporary arrangements of ancient stellar material that have somehow become capable of wonder and thought. When you look up at the stars, you're looking at your distant ancestors, the furnaces where your atoms were born. The nearest star to us after the Sun is Proxima Centauri, about 4.25 light-years away. That means the light you see from Proxima Centauri tonight left that star 4.25 years ago. If Proxima Centauri somehow vanished right now, we wouldn't know about it until 4.25 years from now, when the last light that left before the star disappeared finally reached us. In a very real sense, when we look at the stars, we're looking backward in time. The farther away the star, the further back we're seeing. Some of the stars visible in powerful telescopes are so far away that their light has been traveling toward us for billions of years, since before Earth even existed. When we look at those stars, we're seeing them as they were in the ancient past. They might have changed completely since then, or died, or transformed into something entirely different, but we see them frozen in time, as they were when that light began its journey. The Milky Way, our home galaxy, is a spiral galaxy containing somewhere between 100 and 400 billion stars. On a dark night, far from city lights, you can see it stretching across the sky as a band of milky light, hence its name. What you're seeing is the combined glow of countless distant stars, too far away and too close together for your eye to distinguish individually, blending into that soft, luminous band. You're looking at the disk of our galaxy from inside it, seeing the spiral arms edge on. Our Sun orbits the center of the Milky Way, completing one full orbit every 225 to 250 million years. We call this period a galactic year. In the time it takes for our Sun to travel once round the galaxy, entire species evolve and go extinct on Earth. The last time the Sun was in its current position relative to the galactic center, dinosaurs hadn't yet appeared. The dinosaurs evolved, dominated the planet for over 160 million years, and went extinct, all in less than one galactic year.
Between the stars lies mostly empty space, but not complete emptiness. The interstellar medium, as astronomers call it, contains extremely sparse gas and dust, perhaps 1 or 2 atoms per cubic centimeter. That sounds empty, and by Earth standards it is. But across the vast distances between stars, this tenuous material adds up. It forms dark clouds where stars are born, and it scatters and absorbs starlight, making distant stars appear dimmer and redder than they would otherwise. Stars twinkle, not because they're actually varying in brightness, but because their light passes through Earth's turbulent atmosphere. As pockets of air at different temperatures and densities move around, they bend the starlight slightly, making the star's position appear to jiggle around a tiny bit. Your eye perceives this as twinkling. Planets, by contrast, don't twinkle as much because they're close enough to appear as tiny disks rather than points, so the atmospheric turbulence averages out across the disk. If you could observe stars from space, above the atmosphere, they would shine with perfect, steady light. Some stars pulse with remarkable regularity. Cepheid variables, for example, brighten and dim over periods of days or weeks, their outer layers literally expanding and contracting like a slow cosmic heartbeat. These pulsating stars have been incredibly useful to astronomers because there's a relationship between how long their pulse period is and how bright they truly are. By measuring how long a cepheid takes to pulse and how bright it appears from Earth, astronomers can calculate how far away it must be. This technique helped us measure the distances to nearby galaxies and understand the true scale of the universe. Other variable stars change brightness for different reasons. Eclipsing binaries are pairs of stars that orbit each other in such a way that, from our perspective, one star passes in front of the other, temporarily blocking its light. Eruptive variables experience sudden outbursts, temporarily brightening before fading back to normal. The universe is full of these changing stars, the night sky more dynamic than it appears during a casual glance. When massive stars explode in supernovae, they leave behind either a neutron star or, if the original star was massive enough, a black hole. Neutron stars are extraordinary objects, packing more mass than the Sun into a sphere only about 12 miles across. They're so dense that a teaspoonful of neutron star material would weigh about as much as Mount Everest.
The gravity at the surface of a neutron star is about 200 billion times stronger than Earth's gravity. If you could somehow stand on a neutron star, which you absolutely couldn't, you'd be instantly flattened to an atomic thickness. Some neutron stars spin rapidly, hundreds of times per second, beaming radiation from their magnetic poles. If those beams happen to sweep across Earth, we detect regular pulses of radio waves or other radiation. We call these objects pulsars, and they were initially so baffling when first discovered in 1967 that astronomers briefly considered whether they might be signals from alien civilizations. The regular pulses were so precise, so clock-like, that they seemed artificial. Of course, they're entirely natural, just another example of the universe being stranger and more wonderful than we might have imagined. Stars don't last forever, but their matter does, recycled endlessly through the cosmos. When a star dies, whether in a gentle shedding of its outer layers or a violent supernova explosion, it returns material to the interstellar medium. This enriched gas and dust eventually becomes part of new nebulae, new clouds that will form new stars, new planets, perhaps new life. The universe recycles itself this way, generation after generation of stars, each one enriching the cosmic mix with heavy elements forged in stellar cores. In this sense, stars are deeply connected across time. The atoms in our sun and solar system came from earlier generations of stars. Those atoms will eventually return to space, becoming part of future stars, billions of years from now. Matter flows through the universe, taking different forms, briefly becoming stars or planets or people, then moving on to new configurations. Nothing is truly permanent, but nothing is truly lost either. Looking up at the stars on a clear night connects us to something vast and timeless. Those same stars, or their ancestors, have been watched by countless generations of humans. Ancient peoples navigated by the stars, told stories about them, organized their lives around stellar patterns and movements. The stars we see tonight are essentially the same stars they saw, though if we could somehow compare the night sky precisely, we'd notice that the stars have moved slightly relative to each other due to their individual motions through the galaxy. The ancient light reaching your eyes has traveled through the void for years, decades, centuries, arriving at this exact moment for you to notice. There's something both humbling and comforting about that. The universe is vast, beyond comprehension, filled with stars we can't count, most of them forever beyond our reach, yet we can still see their light, still connect with them across the emptiness, still marvel at their existence. As you drift toward sleep tonight, you might imagine yourself floating among the stars, weightless and peaceful, surrounded by gentle points of light in every direction. Some shine steadily, some pulse slowly, some gleam blue or red or gold. They're impossibly far away, yet their ancient light has traveled all this distance just to reach you, here, now, in this quiet moment. You're made of stardust, literally composed of atoms forged in stellar furnaces billions of years ago, and those atoms will exist long after you're gone, eventually becoming part of new stars, new worlds, continuing the cosmic cycle. The universe is old, vast, and full of wonders we're only beginning to understand. But tonight, you don't need to understand anything. You can simply rest, breathe slowly, and feel small in the best possible way, a tiny part of something infinite and beautiful. The stars will keep shining long after you've fallen asleep, their light crossing the cosmos, indifferent to our daily concerns, constant and quiet and ancient. So let your mind drift among the stars.
Let yourself feel the deep time of the universe, the slow, patient burning of distant suns, the gentle recycling of matter through generation after generation of stellar birth and death. You're connected to all of it, made from it, temporarily aware of your place in the cosmic story. The stars are still there, just as they were billions of years before you existed, just as they'll be billions of years after you exist. That continuity is somehow reassuring, a reminder that the universe continues, vast and mysterious and beautiful, regardless of our small human worries. Tonight, as you close your eyes, remember that you're resting on a planet orbiting a star in a galaxy of hundreds of billions of stars, and that the atoms in your body were born in ancient stars that died long before the Earth existed. If you found this journey through the quiet universe peaceful, consider liking this video and subscribing to Sleepy Space for more calming explorations of the cosmos and beyond. Let the stars guide you into restful sleep, and remember that you're always connected to the infinite beauty above. Sweet dreams, stargazer.